Hi, it's Moser, the quick tutorial on survivorship curves, also known as surviving life. Nothing does. After you've watched this video, you should be able to interpret a survivorship curve and distinguish between type 1, 2, and 3 species. You should also be able to use data to place a species on a survivorship curve when you're given one. So, enough about this. Let's talk about fish. Oh, look how cute. They're little tiny baby fish. Those are actually walleye fry, just about the 2 eyes and a wiggle stage that we've talked about in class. They're tiny, and there are probably, 5,000 or 6,000 of them in that bucket. Well, if they make it long enough, they'll end up looking like this. We call these fingerlings, and they're a little bit bigger. And if they make it a really long time, they'll look like this big, beautiful lady. Oh, isn't she pretty? Yes, she is. So the chart you see down here below, on the x-axis says percentage of maximum lifespan. And on the y-axis says percentage of population alive. Well, now, we all know that on day 0, here, actually that's a little past day 0, but close enough, they're all alive. Everybody is alive. We start off with the entire population having survived. And for a walleye, it's possible that the maximum lifespan is 5 years, and that would be a really old walleye. Well, what do you suppose happens between here and here? Do you think all of those little tiny fry make it to fingerling stage? Oh no. They're very tasty and small and wonderful snacks for all manner of things living in lakes. So it's quite possible that by 10% of their maximum lifespan, maybe 3 months in or so, more than 75% of them have died. So it starts to look pretty grim pretty fast. It's possible that in another 3 months, another good chunk of them have died. Now, of the ones that survive the first 6 months, there's a pretty darn good chance that they will live to 100% of their lifespan, that they'll live a long, healthy life, and they'll end up like this big, beautiful lady. Well, hopefully it's catch and release. So again, with a species like this, boy, if you do make it through the first maybe 10% of your lifespan, you'll be just fine. No worries. But maybe 90% of those individuals who you came into this world with, maybe a full 90% of the little tiny wigglers in that bucket are dead in the first 6 months. Aww. Well, now let's look at some other cute things. Babies! Baby humans! Look at all the baby humans. That's a lot of baby humans. And if baby humans survive long enough, they become, oh, look, it looks like you, human teenagers. These are human adolescents. Well, they might be junior high, but anyway, they're young humans. And if you live long enough, you'll look like these very happy old people, all bright-eyed and white-haired and, ready to go take a nap. So let's think about this same sort of graph for humans. Well, obviously we know that on day 0, starting off, 100% of the humans that are born in that generation are alive. Well, now, and remember, we're answering this for modern industrial world. Do most of these babies make it to here? Yeah, they do. That wasn't always the case with humans. There were times in human history when a majority of infants would have died before their first year of life. But now, because of modern medicine and advances in nutrition and sanitation, life is pretty good. So when you get to 10% of maximum lifespan, let's say 10 years old, you still have most of the individuals of your age. You've still got a cohort. When you get to 20% of maximum lifespan, 20 and 30 and 40, you may have had some die-offs. People do die early. But really, a lot of the individuals who you came into this world with, your class as it were, are still there. Now, once we start to hit those upper numbers, these 70s and the 80s, we do start to see declines. And it drops off pretty fast after that. And by the time we get to 100% of maximum human lifespan, well, they're all dead, because that's what happens. Things die. You knew that, right? Good. So in this case, in this sort of species, most things survive the early part of their life. But once we get to the sort of latter end of the maximum lifespan, it goes downhill pretty fast, and we start losing some every single day. Check your local paper for obituaries if you have questions about that. Oh, more cute babies. These are baby bluebirds. They've just started to get their feathers. They're in the fledgling stage, and pretty soon they'll have even more feathers, and they'll be getting lots more food from their moms and dads. And if they survive long enough, they'll look like this handsome fellow, eating bugs, flying around orchards, doing their thing. Cool. So there's a funny thing about most birds. Obviously, you know by now, if we put this on a chart, at day 0, 100% of your class, or the other organisms that came into this world at the same time you did, are alive. Well, if we look at most bird species, it's sort of a steady drop the whole time. So in other words, life is challenging as a bird, and it doesn't necessarily get more or less challenging because of age. Now, obviously baby birds are vulnerable, probably more so than adults, but life is just risky for birds. It really is. Now, let's put this in the context of survivorship curves, because what you didn't know, the great trick, is that you've been looking at survivorship curves. A survivorship curve shows the likelihood of survival at different ages throughout the life of an organism. So in type 1 species, and that would include us, humans, the chance of dying tends to be smaller until we get very late into life. So most of the organisms survive the early part of life, and once you've survived the early part, it's quite probable you'll live to a very long age. In type 3 species, and yes, I am doing these out of order, most of the organisms that come into the world at the same time die young. Your chances of dying while you're young are very, very great. But if you make it through those early years, you have a high chance of surviving to a very ripe old age. And then you have these, the type 2s. Many bird species fall into this category. Your chance of dying is pretty much the same every single day you wake up, and so we tend to see a straight line. Okay, so let's practice. Without knowing what species this is, would this be a species that has a good chance of dying in childhood, or a better chance of living to a ripe old age? You can pause this. Got an answer jotted down? That's right, this is a type 1 organism. This organism is most likely to live a pretty long life. Pretty long life because most of the members of this species live to old age, and then their numbers start to decline. Let's try another one. Now, looking at this species, is this one where individuals in this species are likely to die when they're young, or do most of them live to old age and then die? I'll pause it. You can pause it too. That's right. This is a type 3 species. They have a pretty significant risk of dying young, but once they do make it to old age, there's not much of a die-off after that. So that only leaves one, which is, of course, our type 2, where every single day that you wake up is hazardous. Those type 3 species, type 2 species, every single day carries a big risk. And it doesn't really get any better. Well, the good news is it doesn't really get any worse. And just like all of them, in the end, by the time we get to 100% of life expectancy, they're all dead, because life is a wonderful thing, but it's also terminal. That's it. Do you think you can interpret a survivorship curve? In other words, can you look at a survivorship curve and tell when an organism's chances of dying are the highest? Can you tell the difference between a type 1, 2, and 3 species? And do you think you could use data to place a species on a survivorship curve? Well, I hope so. That's it. See you later.